Everybody, this is Todd Frazee, and this is the video tutorial for the S60-131 CAD work for the secondary cylinder. And it is a turn part with a rib, series of ribs in it. Those are to increase the surface area so that the part looks like a heat sink, air cooled. And a piston runs up and down inside this cylinder. Pretty neat part, but it looks a little more complicated than it really is. All right, so let's look at our drawing, and our front view is what we want to represent in the front view of what we're modeling. We're going to revolve it without the ribs, and we'll include the hole in the center in that revolve. And then we'll come back and make a single groove and use a pattern to duplicate the groove pattern. This is another brass part. So let's go to SolidWorks. And we're going to create a new part. Make sure it's in ANSI and inch. And once that's up, we're going to select part. We're going to hit OK. Alright, so we're going to make our planes visible as we have on several others. And we want the side of the cylinder to be shown in the front plane. And if we look at our drawing, all the dimensions more or less come off this right-hand side. So we're going to put that up against the right side viewing plane. So we'll go sketch. And we're going to sketch on the front plane. And we're basically going to draw a rectangle. And off of that rectangle, we're going to, off the center, we're going to put in a center line. And we're going to make that coincident to the end of the rectangle we've just made. So our center of rotation will be this center line rotating around this block up here. Alright, so we go back to our drawing, and our overall length is 1 inch 80 thousandths. So we're going to put a dimension on the overall length of 1 inch 80 thousandths. Okay, so let's put our dimension from center line to our inside bore. You go from center line to inside bore, and we're going to click out here and go back to our drawing. And our drawing says it's 200 to 198 thousandths. So the mean and the tolerance on that would be 0.199. And we're going to type in 0.199. Okay, and then we have one more diameter, which goes from outside edge to center line. And if we go back to our drawing, that's 455 to 453. So we're going to say 454 is right in the middle of that tolerance. 0.454, 454 thousandths. And we've got the pretty much fully constrained sketch we need to create this revolve. Okay, so if we want to be thorough, we can take this endpoint and we can make it endpoint of our center line and make it vertically aligned with our sketch. Okay, we're going to exit sketch. We're going to go to a 3D view. And we're going to create a feature, and that feature is going to be a revolve boss. And we're going to accept that feature, and we've got this bushing looking piece. And we're ready to put in our groove feature. Okay, so we're going to make one groove, and that's going to be a revolve cut. So we're going to go to Sketch. We're going to make our sketch on the front viewing plane. And we're going to look at the model from the front viewing plane. And we're going to go back and reference our drawing, and it's 140 thousandths from the edge, and it's 40 thousandths by 40 thousandths. There's actually 12 instances. This is backwards. It should be 11 on the crest and 12 on the groove. So if you have this version of the drawing, the quantity's backwards on this. You need to update that. Okay, here we go. So we're going to draw this first groove here. Okay, so we're going to take a rectangle tool and we're going to touch on the silhouette so that it sticks to one line with a coincident relationship. And then we're going to do a dimension from the end of the part to the inside of the groove, and that was 140 thousandths, so 0.14. And then our groove has a width of 0.04 and a depth of 0.04, and that gives us our initial groove profile. Okay, we're going to look at this at a 3D view. We're going to exit the sketch, which should be fully constrained, and we're going to go to features, and we're going to use instead of drawing a center line, we already have an axis here. It's just hidden. We're going to make temporary axes visible, so that's what this blue line is. And we're going to do a revolved cut using the axes that we just shown and the default sketch that we had highlighted. And so that does our revolve all the way around, and we're going to accept that cut. Okay. Now it's a good time to save, and the next step is we're going to do a pattern. So we're going up to linear pattern, and it asks for a couple directions. Okay, so our direction is going to, the first direction is going to be in the direction of the axis, and our groove is 40 thousandths width, and the land on top is the rib on top is 40 thousandths. So if we add those together, our combined offset should be 80 thousandths. And the feature that we're going to repeat is the groove. Now it looks like we need to reverse the direction. And right now we're only making 2 grooves, and that counts the original. Alright, so we should have 12 instances of this groove. And it leaves a smaller land at the end at nominal of tolerance. The second direction, we're going to select pattern seed only, and it really doesn't matter which axis you pick in this instance, but it's not going to move in the other axis. Okay, we just finished. Hit accept, and there we go. We have our finished part for the dash 131 part. Now you can change the properties of brass. Of course, this one's brass. I'm going to hide the planes, and I'm going to go ahead and make the temporary axes invisible. But there you go. You've made the dash 131, and I'll catch you on the next one.